All right, and you're back to the second part of day 93, volumes by cross sections, part one. We'll do some more cross sections tomorrow, but for now, you have already tried these three practice problems and you're just here to see if you did them right. You can always skip to the end to see the right answer. First one's calculator active, and there's these two kind of aggressive equations here. I don't really like that. What are we trying to do? We're trying to find region S, that's over here, and we're trying to say that's the base of a solid. People are dancing on it. And the cross sections perpendicular to the x-axis are squares. Oh, we can do this. This one just has a couple steps. First step, we need to find the area of a square. And as a reminder, the area of a square is just base times height. So let's actually draw a square. Here's this. This kind of goes up here, over. Here's my square. Base, height, they're exactly the same, nothing too terrible. So my area function then, a of x, is going to be, I need more space. A of x is going to be the base times the height, but because they're the same, it's really just going to be the base squared. What is the base? Looks like a top minus bottom here. I see a couple functions going on. We have this one curvy one in blue, and then we have this nice peaky trophy one. Looks like that. Wonderful. Blue minus red. Well, what's the blue? What's the red? Well, if you're not sure, x to the fourth is probably going to be this curvy red one, and f of x is going to be the blue one. Let's just go ahead and graph those quickly. 1x e to the x squared minus 2x. I've got my calculator right here. Still had my other graphs in here. Let's delete everything 3 times, nothing bad. So we needed to do 1 plus x e to the x squared minus 2x. 1 plus x plus e to the x squared minus 2x. Hopefully that was right. 1 plus x e to the x squared minus 2x. Crushing it. Nice. Okay, and then we have a second function coming through. My second function is x to the fourth minus 6.5x squared. Who comes up with these equations? X to the fourth minus 6.5 x squared, oops, and it's in the powers set, so we need to do that again, minus 6.5 x squared, and finishing off with, it looks like plus 6x plus 2, plus 6x plus 2. Hopefully you're doing this at the same time, so I'm not just here talking to myself crazy. Plus 6x plus 2. Awesome. Okay, and can we see that little shape in here? Yes, we can. Looks like the blue one is the e to the x one. The red curvy one, as I guessed, was x to the fourth. So let's finish this off. So blue one was again this e to the x function. Red one was our quartic, our x to the fourth, and it's blue minus red, top minus bottom. So we're going to be clever here and say that the top function is f of x and the bottom function is g of x. So we're just going to write it like this. There's no reason to rewrite the whole function. They already named them for you. So this right here then is the base, but the height that's coming over is the same as the base. So we just have to do it a second time. F of x minus g of x. Or hopefully you guys just skipped to the easier way to write this, which is just f of x minus g of x squared. Okay, that's the hard part. Now we do the easier part. The easier part is, well, this is a square, but we want volume, we want 3 dimensions, so we've got to go ahead and give this guy right here 3 dimensions. Okay, you can go really detailed if you want. There's our 3 dimensions. This is along the x-axis. The width I gave it is dx. So my volume formula, my v of x formula, then is going to be f of x minus g of x, which is the area function, times our third dimension, which is dx. All right, so let's finish it off. We need to find the volume. That's the integral of f of x minus g of x squared dx from something to something. Well, let's see. It's this point, this x value here. This x value at least is nice. That's an x value at 2, so I know it ends at 2, but where do they intersect? Oh, well, luckily we already graphed this. Go us. Let's see what we can do. We need to find their intersection point. So that's going to be our menu, analyze graph, intersection. We need to be over here somewhere. And then over here, there we go. Intersection 1.03. I think we need some more decimals on that. In fact, we should probably just store this. control store what variable. I just use A, it's the first letter, why not, and it's bolded. Alright, just to make sure I got it this time, we're going to do A down here. Oh good, alright, so we've got that variable. Interesting that it is the same variable as up above. It's like we've seen this equation somewhere before. So let's go ahead and do our integral. So we're going from A to this of all this function, and we can just type that into our wonderful graphing calculator, right? Menu, calculus, integral. We're going from A up to 2. And then I didn't define my functions on this, you could have, but the functions are in our graph, and I believe the first one that I graphed, which was the top function, is going to be f1 of x. And then we have to subtract the bottom function, which is g of x. Now, the nice part is, oops, not g of x, sorry, it should be f2 of x. f2 of x, getting ahead of myself. The nice part is, if you screw up the order here, after you subtract them, it's either going to be negative or positive, but same value. When you square it, it becomes positive anyway, so it doesn't really matter. Don't tell anyone. You should try to get the right order, but it doesn't really matter. And then enter, and we're set. 1.294. 1.294, and that is our volume if we were to build a shape out of square cross sections. Cool. All right, let's move on. Question 2, non-calculator active. This one might take a little bit longer. Let's see. R is our region. Wonderful. We should probably outline these with colors. 2x squared, that's an upwards facing parabola. That's got to be this one right here. This is going to be my f of x. And then my second one is my cosine function, which normally starts at 0, 1. It might be somewhere else now. 0, 4, I guess I should read that. And it ends at 2. Okay, what are we trying to do? Each cross-section perpendicular to the x-axis is a square. Oh, this is exciting. It's the same thing again. So let's do the same thing. First thing is I'm going to draw a square. Looks something like this. Great. It's a pretty good square too. I'm proud of myself. The base is going to be the green function minus the red function. So that means that my area function then, my a of x, area of any x value, we can do this one faster this time I think. Base times height is going to be squared. Top function, g of x, bottom function, f of x, and we end up here. Looks good so far. Step 2, we need to write our volume function, and I should pick a different color. My volume, I'm going to give this a little bit of width this time. Looks something like that. Here is my volume. Excellent. And that width is along the x-axis dx, so my volume function is going to be the area, so g of x minus f of x squared times the extra width. Cool. And then last but not least, they asked us to write but do not evaluate. Oh, that's exciting. We're going to write an integral, so we need to sum up all of these squares that are popping off of the page at us from where to where. Well, the first square is going to be created at 0. The last one's at 2, so 0 to 2. And we're done. Easy. All right, on to the third. Oof, calculator active again. Natural log of x and 5 minus x. I might as well continue the same thing I've done in the past. Clear out all this history just in case. Menu, actions, clear history is 5. And just to make sure our variables don't get weird, actions, and then if you do 4, it's going to clear all your variables. Alright, nothing too bad there. And then we should also clear out our graphs. Delete 3 times. Excellent. And we're looking good. So there were 2 functions here. We needed to graph the function natural log of x. There we go. Natural log, I thought there we went. There we go. Natural log of x, and we also need to graph the function 5 minus x. There are those 2. We can see our kind of triangular region in here, and I bet we're going to need their intersection, so let's go ahead and do that too. Analyze graph. Intersection, you'll start to get good at all these shortcuts here, which is excellent. There's the first one, here's the second one, there's my intersection. Uh-oh, I moved everything. I think I can do Control Z and undo it. Excellent. Let's try this again. Nope, don't want to do that. Awkward. Okay, you're just being difficult. So I'm going to go ahead and store you. So Control Store. Nope, didn't work. Second try. Click. All right, there we go. Control store. We're going to store this as A. Excellent. It'll store many variables, or many decimals rather, but let's just double check. There's A. Does it have lots of numbers past the decimal place? It does. Excellent. All right, 3.693. Now let's get to our problem. What are we doing here? All right, for the solid, each cross-section is perpendicular to the y-axis this time. Okay, all right. So we're going to have to go through and draw another square. So here, it did say square, right? Yep, wonderful. So here is, it's going to be a large square, but that's okay. Here is my square popping out of the page at us, and our square has these two sides, and it looks like though that this square is going to be composed of the right function minus the left function. So this is my right function, y equals 5 minus x, and you'll realize in a bit that we'll need to solve for x, add 5 over, so x is going to equal y plus 5. And at the same time, we have this second function over here. This one is currently y equals the natural log of x. We solved this earlier. It gave us x equals e to the y. Now, the next thing we'll need, and you might be asking, well, how did you know that you had to solve those for x so quickly? Well, imagine if we gave this some width like we did before. Here is my width right here, right? You'll notice that this width runs along which axis? If you extend it out, it runs along the y-axis. So our width here is going to be dy. And if this is in terms of y, every equation better have y in it. So let's get this done. First step, we need to go ahead and write our area function. And our area function, I've been doing this in blue, let's stay consistent. Our area function is going to be the right function, that's our y plus 5, minus the left function, which is e to the y, but that's just going to be the base. We also need to multiply it by the height, base times height, right there. So again, the base is the left function, the right function minus the left function. The height will be the same. We need to multiply those together, and so we end up here. All right, then we get our volume function. Our volume function is just going to be our base, looks like this, times the height, times dy. Notice everything's in terms of y. I'm not sure why I'm putting a of x and v of x. Should probably be y's as we go through if everything's in terms of y. And then last but not least, we need to go ahead and get our integral. We're going to integrate our volume. We're going to sum up all of these volumes, something like this. But then from where to where? Well, everything has to be in terms of y, so we need y values here. These are x values, so let's go y values. Okay, the lowest y value has got to be a y of 0. The highest y value has to do with this point. And, of course, unfortunately, I picked the wrong value to hold on to. We need the y value that's over here. Great job. 1.31, there we go. Going at least a few decimals, 1.3065. 1.3065, something like that. There we go. And what else do we have to do, right? But do not evaluate. Okay, we're done. So, as long as you're comfortable with squares, a little bit of rectangles, side to side, up and down, you have conquered today. Well done.